Hey guys, so I am adding these videos so that you guys can come and if you have questions on the problems that you did on your own and you'd like to see me working them out, then you can come watch these videos and fast forward to the problem that you would like to see me worked out and so forth. As we're going, I'll add some tidbits on how it was graded and thought processes and things like that. Before I forget, when I did the original YouTube video, I included the problem from 2019, and I went back and I looked up what the global point average was for this problem in 2019, and the global average was 5.1 out of 9 points for this. So if you go back and redo this problem yourself, and then you can come back and score it yourself, know that the global average on it was 5.1 out of the 9 points possible. Okay, so we are still doing topic 3, which is rate in minus rate out. And again, we let A be the amount present. Maybe it's the number of cars in the tunnel, maybe it's the amount of water in a pipe, whatever it is, it's the amount, all right? In that case, then A prime, the rate of change of the amount, will be the rate in minus the rate out. And setting up a fundamental theorem equation, we'd have A at our higher time minus A at the earlier time will be the integral from the earlier to the later time of A prime dt. Okay, so the first problem that I had you guys do on your own was 2018, and I went and looked up the global average on this problem, and the global average was 4.2 points out of the 9 points possible, so rather low for this problem. 4 out of the 9 points was the average. Okay, so let's take a look at this problem. It says it's a calculator problem. These data these rate in minus rate out problems often are calculator active. It says people enter a line for an escalator at this rate. So this is the rate in, at a rate modeled by the function r given by this piecewise function. So I know that piecewise functions are sometimes a little confusing, but this time it kind of makes sense. The rate getting into the line for the escalator is this equation for this time, and the rate is 0 for time greater than 300. Turns out those are in seconds. So after 300 seconds, the rate is 0. Between 0 and 300 seconds, this equation models the rate that people enter the line. Okay? R is measured in people per second. T is measured in seconds. As people get on the escalator, they exit the line at a constant rate of 0.7 person per second. Okay, so that's the 0.7 is the rate out. So the R of t is the rate in, 0.7 is the rate out. And then they tell us that there are 20 people in line at time 0. So this is calculator active. Let me tell you what I'm about to do. I'm going to come and in the problem I will say this, but I'm going to let A be the amount of people, the number of people in line at time t. Okay, then A prime will be my rate in, which is R, minus my rate out, which is 0.7. Okay, note that this is not 0.7 t, it is just 0.7. It's a common thing. I see some kids try to, for some reason, they want to add a t to that. But this is just 0.7, not 0.7 t. Rate in minus rate out. So in for y1, I'm going to put my expression for r, that's my rate in. In for y2, I'm going to put 0.7, that's my rate out. Don't really have to do the 0.7 for Y2 because it's just 0.7, but I'm still going to do it. And then in for Y3, I'm going to put my rate in minus my rate out. So let's go do that. I have started my R equation here. Got it started there, so then I need to also multiply by 1 minus t over 300 to the 7th power. Okay, so there's my Y1. And then for Y2, I'm going to put 0.7. And then for Y3, I'll put Y1 minus Y2. So remember that this Y3 will represent my A prime of t, the rate of change of the amount of people in line. Okay, part A. How many people enter the line from 0 to 300 seconds? How many people just enter? It has nothing to do with exiting. How many people enter the line? So that will be the difference between the amount of people at time 0 and the amount of people at time 300. So, and that's just how many people enter. So that will give us the number of people who just enter from that time period. So back to our calculator, I'm going to have math 9 for my integral 0 to 300, and then just my y1 function. Oops. 270 people. And that's that. Okay. Part B. During the time from 0 to 300, there are always people in line. How many people are in line at time 300? How many people are in line at time 300? Okay, so they told me that there are 20 people in line at time 0. That gives me the amount at time 0. Now they're asking me for the amount at time 300. Fundamental theorem. They want an amount. I know one amount and the rate. I know the rate. So first of all, I need to tell AP what this A means. So I'm going to say let A of t be the number of people in line at time t. Then fundamental theorem, so A at 300, the amount of people in line at time 300, minus the amount of people in line at time 0, must be the integral from 0 to 300 of A prime of t. Okay, at time 0, the amount of people is 20. They gave us that. Taking that to the other side. Plus, all right, A prime is going to be the rate in minus the rate out. So I need to tell AP that. So that's my rate in minus my rate out, and the rest will just be calculator. This is what we have stored in for Y3. So I can use my calculator for this. So 20 plus math 9, 0 to 300, Y3, so at time 300 seconds, there are 80 people in line. Okay. All right, so FYI, just on those two parts, let's see how AP scored those. On part 1, that was worth 2 points. It was 1 point for the integral, 1 point for the answer. And I find that every one of these problems has a question like this, either how many enter or how many exit or whatever. Usually part A is very similar to that. In Part B, this was also worth 2 points total. 1 point for considers rate out. So considers rate out. That means somewhere on your paper you involve that 0.7 rate. And then 1 point for the answer. So I think both of these problems, A and B, are very doable. And keep in mind that the global average was 4.2. So even just getting these two, you're almost at that global average. All right, let's go look at Part C. For time greater than 300. So now we're going above 300. So remember, above 300, nobody enters the line. All right? For time greater than 300, what is the first time that there are no people in line for the escalator? So people are still exiting. People are still exiting. As people get on the escalator, they exit at a constant rate of 0.7. There are no time restrictions for that. So they're going to continue to get off the escalator, or get out of the line for the escalator at a rate of 0.7. But above time 300, nobody enters the line. So we're looking for the time when the amount of people is 0, right? So we're looking for some time when the amount of people is 0. I'm going to let some other letter, I'm going to call it x. Let x be the time when there are no people in line. So we're looking for x here. All right. So I'm going to set up fundamental theorem. The amount of people at time x, which I know will be 0, right, minus the amount of people at time 300 must be the integral from 300 to x. Remember, x is bigger than 300. Integral from 0 to x of a prime. Okay? So a of x will be 0. A of 300 we found in our Part B, that's 80. That will equal integral 300 to x of, okay, now I need a prime. Now be careful, because a prime, it is r minus 0.7, but r is 0 for time greater than 300, which is where this integral is. So in place of the r, I need to put a 0. So this is 0 minus 0.7 dt. Okay? And this is an integral that we can solve by hand very easily. So we have negative 80 is equal to, all right, this is just negative 0.7 times the difference of x and 300. So negative 0.7 times x minus 300. Because this is just a constant, you can do that, right? So now we just have this little equation to solve for x. I'm going to divide both sides by the negative 0.7, and then add 300 to both sides. And that would be a safe stop spot if we wanted to find out what time that was. We would get 400. I think I'll safe stop there though. I get 414.286, or they would take 0.285. Okay, now here's how they scored this one, you guys. This one was just worth 1 point. That whole thing was worth 1 point for the answer. Now remember, to get that 1 point for the answer, you needed to show how you got it. So there are other ways to find that time, but this is one way. You had to show how you found that answer. Just putting a number is no good. you have to show where you got that answer from. Okay, sorry. Part D. All right, we're back to 0 to 300. For 0 to 300, at what time is the number of people in line a minimum? So we want to minimize A here for that time period. To the nearest whole number, find the number of people in line at that time. So we want the time and we want the number of people at that time, that A is a minimum. So an absolute min, closed interval test. So I'm going to put time and what I am minimizing on my closed interval test. I do have a closed interval, 0 and 300, and then I also need to include any times that make A prime 0. So I'm going to come off to the side and say A prime is equal to 0 at time equal. Okay, so now back to my calculator. I'm going to back to this. A prime, remember, is just our y3. So I'm going to turn off that graph and turn off that graph. And then down here, since I'm going to be finding where it's 0, I'm going to add 0 here so I can just use the intersection feature on the calculator. Let's see, time is between 0 and 300, right? I'm going to turn off that x scale so we don't have 300 dashes on my x-axis. And for A prime, I'm not sure what this will be. I'm not sure how large it will get. So I think I'm just going to go, I think I'll start with -10 to 10 and then adjust as I need to. Okay, let's see what that gives me. Well, I see that I didn't need -10 to 10. I probably only needed like -2 to 3 maybe, but this is okay. This tells me a lot here. So I'm going to do second calc intersect. Come over, I like to grab the lower one first. You can grab either one, of course. So that time that A prime is 0 is 33.013. And there's another time, second calc 5, whoops, second calc 5. Come over closer to this one, enter, enter, enter. 166.575. And I just realized that I never did go and save that first one. I should have saved that first one. I'll go back and have to get that again. So, but first let me write this down on my chart, 33.013 and 166.575. Okay, before I leave my graph though, let's take a look. This is A prime, right? We're looking for a minimum. And this is A prime. I know that A will have a minimum when A prime goes from negative to positive. This time value here is where A prime goes from negative to positive. So that's going to be a relative min, so it possibly is a maximum. It possibly is an absolute min. This time, at this time, A prime goes from positive to negative. That is where A has a relative max. So this 166 is where A has a relative max. And A cannot be an absolute min at the spot where A has a relative max. So I'm going to put relative max here, and then I don't have to worry about finding A in that spot. But I definitely want to go back and grab that first time value and save it in my calculator so I get an accurate answer. So there it is again. Go back here and I'm going to store that X value in for A, and I think I will say for AP, let A equal 33.013. and it's the full value that I'm letting A be. That way I don't have to keep rewriting 33.013. Okay? All right. Now, we need A at these times, at these 3 times. We were given what A was at time 0. We were given that. That was 20. We found along our way, we found what A at 300 was, and that was 80. So all we have to do is find A at this time, and we can use either time 0 or time 300 together with A prime to get the amount at this time. So I'm going to say A, and now all of a sudden I see a little problem here. I see that I let A be that time, and I also have A representing something else. So I'm just going to tell AP, I'm not going to let that be A, I'm going to let it be B. In my calculator it really doesn't matter, but for AP I don't want to let A be 2 different things. So I'm going to say A at time B minus A at time 0 is the integral from 0 to B of A prime. So A at time B is going to be 20 plus 0 to B. A prime is R minus 0.7. Okay? So now to the calculator. Alright, so we have 20 plus math 9, 0, 2, and I stored that in for A, that time in for A. And then this is my Y3. So 3.803. Okay. And 3.803. Okay. And so I'm ready for my answer because I have found out what my absolute minimum value of A is. Keep in mind they tell us that we are supposed to give that to the nearest whole number, so I'm going to say that that's approximately 4 people in line. So I'm ready to write my answer. So for 0 to 300, the minimum number of people in line is 4 at time 33.013. And it is by the closed, to justify, you could say by closed interval test, but they see that we use the closed interval test, so we don't have to write that. It's clear that that's what we use. We justified. Okay? All right, this problem was worth 4 points. So 1 point for considers R of t minus 0.7 is equal to 0. So we considered that when we said this, because A prime is R minus 0.7. 1 point for identifies t equals 33.013. So when you identify that time, you got that point. 1 point for your answers. Our 2 answers here. And 1 point for the justification, the closed interval test. So 4 points. So even if you didn't get all of it, you may very well have gotten a point or 2 as you went along. Okay? So that's that one. If you still have questions, come to one of my tutorings on Zoom or in the classroom someday, and we'll go over that. All right, this is the problem from 2014. It was number 1 on the BC exam. And before I start this is not a RateIn minus RateOut problem, but it does deal with rates. Every time when I'm looking at the year's FRQs, I take each problem and I put it into the most appropriate category I can think of. And this is the most appropriate category I could think of for this particular problem. All right. So grass clippings are placed in a bin where they decompose. For time between 0 and 30, the amount of grass clippings remaining in the bin is modeled by this. So this is the amount in the bin of grass clippings. It's measured in pounds, and T is measured in days. Okay, so over the course of about a month. All right, part A. Find the average rate of change of A. Average rate of change of A over the time interval. Indicate units of measure, so we can't forget that. Usually I come over here and do something to remind myself later at the end of the problem to put units on. Okay? So we need to know what average rate of change of any function is. Okay? Average rate of change, think delta for average. Delta A over delta T. That's the average rate of change. And here is your delta T right here. So I need A at 30 minus A at 0 divided by 30 minus 0. And that will be the average rate of change of A. And they gave us A. So I'm going to come over here and clear this out. I'm going to go back to my y equals screen, clear out my old problem. And up here for y1, I'm going to put my A of t function. So 6.687.931 to the t, which will be x for me. I do a quick look to make sure I put it in right every time. Every time I do a quick look to make sure I put it in right. All right, so now home screen, and we need A at 30, so I need y1 at 30 minus y1 at 0. That's my numerator, and now I'm going to divide that by 30 for my denominator. So this is the average rate of change of A over those 30 days. So negative 0.197. And here come the units. So remember, to find units, you take the units of the top and you divide it by the units of the bottom. So the top is in pounds, the bottom is in days. So my units will be pounds per day. And you can totally write that pounds per day like that. Either way is fine. Okay? This was just worth 1 point. Answer with units. So if you did not give units, you did not get anything for that. Okay? All right, part B. Find the value of A prime at 15, and then using correct units, interpret the meaning of the value in the context of the problem. So first, A prime of 15, that's just a calculator question because I can do that in my calculator. I have A, so I can find A prime. So math 8, with respect to time, for me that's x, of A at day 15. So there is my answer, negative 0.164. So there's the value of A prime of 16, and now I need to interpret that value. So I'm going to say this is this is the rate of change of the amount. So this is the rate of change of the amount of grass in the bin in pounds per day on day t equals 15. Okay? That's one way to correctly interpret the meaning of that. Another way would be to say that on day 15, the amount of grass in the bin is decreasing at a rate of 0.164 pounds per day. That would be another way to interpret that meaning, okay? And I'm sure there are other ways to correctly express that meaning. Those work well, okay? This part of the question was worth 2 points. 1 point for your A prime of 15, 1 point for the interpretation with units. So remember, in any interpretation, yes, say what it is. It's the rate of change of the amount of grass. But you also need 2 sets of units, pounds per day and days. It's the units for the time, okay? You could have also said at t equals 15 days, and that would be fine too. But you need days, and you need pounds per day, and you need to say what it is. Okay. Next up, find the time t for which the amount of grass clippings in the bin, so that's A. We want the time that A is equal to the average amount of grass clippings in the bin over the time interval from 0 to 30. So first I'm going to find the average amount of grass clippings from 0 to 30, and then I'll find the time that A is equal to that number. So A average from 0 to 30 will equal. Now we need our function, our expression for the average value of any function. So that is 1 over b minus a integral b to a, b to a 30 up here. That's a 30 of the function that we are finding the average of. Remember, you're adding up your test scores to get your average test score. Okay? So this can go straight into our calculator. So 1 over 30, math 9, 0 to 30 of y1, 2.753. 2.753. Okay? And now I'm going to find the time that A is equal to that. So A of t is equal to 2.753 at t equals, okay, so that number, I want to find when A is equal to that number. So I'm going to store that number in for some letter. Oops, let me get out of there. I'm going to store that number in for some letter, like A. And then on my y equals screen, I can come here and put A, and now I can just find where those two graphs intersect. I'm going to use an appropriate window, 0 to 30, because those are my times available. And I want to make sure my y's include 2.753. And the way I have it, they do. I'm just going to click enter or click graph and see what this gives me. Oh, that was pretty nice. Okay, second calc 5, enter, enter, enter. So this is the time that the amount is equal to what I need it to equal. So 12.415. Okay, this part was worth 2 points. 1 point for the average value expression. That was our average value expression, and then 1 point for the answer that time. For the last part of this problem, it begins for t greater than 30. Okay, so we've only been from 0 to 30 up until now, but now it says for t greater than 30, L of t, the linear approximation to A at time 30, we'll have to think about what that means, is a better model for the amount of grass clippings remaining in the bin. So for time greater than 30, we no longer want to use this for the amount. Now we want to use this for the amount of grass in the bin. Use L of t to predict the time when there will be 0.5 pounds of grass remaining in the bin. And of course show the work that leads to your answer. I always laugh when I see that because they won't take an answer unless you show work that leads to your answer. So I'm not sure why sometimes they say that. It's a little misleading because they always need that. Okay. All right, so first of all, the linear approximation to A at time 30. It's a line because it's linear, right? It's a line when time is 30. Okay? So the first thing we're going to do is we're going to find L of t, that line. Okay? So for any line, we need a point and a slope. So the point is when time is 30. When time is 30. So when time is 30, the amount is what? When time is 30, what is the amount? And we can find that at time 30, the amount was this because that was still valid for time 30. So the amount is A of 30. Okay, we can find that. We can get a value for that. If you want to find out that number, it's just Y1 at 30. So that's the amount of grass at time 30. Okay. I think I'm just going to leave it like that though, but that is the amount at time 30. Okay. All right. For the slope is A prime at 30. A prime at 30. And we could find a value for that as well because we know what A is. A prime, there's A prime at time 30 is that. Okay, so I know the point and I know a slope. So I can write the equation of the line, y minus the y value is A at 30, must equal the slope times x minus the x value 30. So y will equal A of 30 plus A prime of 30 times x minus 30. Changing this to the problem, y is our linear approximation, L of t. X is our time. Okay. And now we want to use LT. So that is our LT. We could put numbers in. We could put numbers in for, I think I will just put numbers in for these up here. This was 0.783 and this was negative 0.056. Okay, so now we want to use LT to predict the time when there will be 0.5 pounds of grass. So L of t is the amount of grass now. So we're putting 0.5 in for that. And we are solving over here for t. Okay? Solving for t. So I'm going to subtract A of 30 on both sides, then divide by A prime of 30, And then I'll be left with t minus 30, so then I'll add 30, and that will give me t. And actually, let me go ahead and find out what that is. Okay. All right, so we have on top, we have 0.5 minus a of 30. A of 30 is right here. Okay, divided by a prime of 30. That's right there. And then I want to add 30. Okay, 35.054. Okay. So, a little tricky one. Part D's are often tricky. Okay. This was worth 4 points, 2 points for our expression for L of t, our expression for L of t. So that was pretty meaty here. Finding L of t was worth 2 points, I think. Okay, point and slope, worth 2 points. 1 point for setting L of t equal to 0.5. So down here where I set L of t equal to 0.5, that gave me a point. And then 1 point for the answer. I remember grading this problem in the past, and a lot of people were able to get that L of t as 0.5, even if they didn't really get the right L of t, or they didn't quite know what to do for L of t, they were able to get that L of t is equal to 0.5. So at least every time you get a point, it's worth something. So try to get every point you can, okay? Don't give up on these problems. Keep working. Okay, let's take a look at 2013. This is BC 2013, number 1 with a calculator. Okay. On a certain workday, the rate in tons per hour at which unprocessed gravel arrives at a gravel processing plant is modeled by this function. So this is the rate that gravel arrives. So this is our RateIn. Okay? T is measured in hours from 0 to 8. At the beginning of the workday, the plant has 500 tons of unprocessed gravel. They're giving me an initial condition. The amount of gravel at time 0 is 500, initial condition. During the hours of operation from 0 to 8, the plant processes gravel at a constant rate of 100 tons per hour. The plant processes it. So this is our RateOut. Okay? It's a constant rate. So it comes in unprocessed and it leaves processed, right? So that's our RateOut. All right, this is definitely a RateIn, RateOut problem. We're dealing with it. In my calculator, I will put Y1 is equal to the RateIn. I will put Y2 is equal to the RateOut. And for Y3, I will put Y1 minus Y2 because that will be my derivative of the amount. That's the rate of change of the amount at the plant at any given time that is still unprocessed. Okay? So that's what I will put in, and I'll go ahead and do that. All right, go back here, delete, clear this out. Okay, so 90 plus 45 cosine t squared over 18. And as I'm looking at that, before I push enter, I always take a look at that. And then 500 for my rate, I'm not 500, 100 for my RateOut, right? And then for Y3, Y1 minus Y2. Okay, and then I like to put 0 down here, but we may or may not need it, or we may need something else. I like to have that in there. Okay. Part A, find G prime of 5. Well, that's easy because they give me G. I have a calculator. I can find G prime at any number that I want. So G prime at 5. I call these gimme. These are just a gimme problems. I don't expect this on 2020 because it's just so simple. But you never know. Maybe it'll be there. Okay. So math 8 with respect to time of G, which is my Y1, at time 5. So negative 24.588, or they would also accept 0.587. Okay, did they ask me to give units for this? No, but I need to use units in my interpretation, like we always do. So G is the rate that unprocessed gravel is arriving. G prime then is the rate that the rate is arriving, of gravel arriving, okay? So that means since G prime is negative, that means at time 5, the rate that gravel arrives at the plant, this is the rate that gravel arrives at the plant, is decreasing at this rate. So that's what I'm going to say. This means at t equals 5 hours, I'm describing what G is first. The rate that gravel arrives at the plant, is decreasing at a rate, this rate is the prime part, of 24.588 tons per hour. Tons per hour is what G is measured in, and then I need another per hour for the prime part, right? So tons per hour per hour. You could also say that, of course, as tons per hour squared, and that's fine too. Okay, that's what I would probably do usually, but this will also work. Okay, so again, G is measured, where does it say that? G is measured in tons per hour. That's just G. So G prime would be tons per hour, right? Okay, notice that I said decreasing at a rate of 24.588. You could also say the rate is the rate that gravel, I didn't put gravel. Goodness, I'm glad I looked at that again. The rate that gravel arrives at the plant is, you could also say, changing at a rate of, and then you would put negative, then you would put the negative in there. But if you say it's decreasing at a rate of, you don't want to put a negative here, because then you'd be like saying decreasing at a negative rate, and that's not what it's doing. It's decreasing at 24.588, or you could say it's changing at negative 24.588. Okay? All right, this part of the problem was worth 2 points. 1 point for G prime at 5, not 15, 5, and 1 point for the interpretation with units. Okay, remember, 2 sets of units, hours and tons per hour squared. 2 sets of units, okay? All right, part B. Find the total amount of unprocessed gravel that arrives at the plant during those hours of operation 0 to 8. So just arrives. Nothing about leaving, just arriving. So that's our 0 to 8. of G of T. That's the expected one on these types of problems. So Math 9, 0 to 8 of G of T is my Y1. So 825.551. Okay, they didn't ask for units here, but remember G is the rate that gravel is arriving, so this would be in just tons. If they needed units, it would just be in tons. When you integrate the rate of tons per hour, you'll just get tons back. Okay? This was worth 2 points. 1 point for your integral, 1 point for your answer. Do not forget your DTs. Do not. Okay? All right. Part C is the amount of unprocessed gravel, is the amount increasing or decreasing at 5 hours. Show the work that leads to your answer. All right. Is the amount. So here's where I'm going to say let A be the amount of unprocessed gravel in the plant at time T. All right. Then A prime is the rate in minus the rate out. Rate in minus rate out. Okay. Now we want to know, is A this is the amount is A, the amount of unprocessed gravel, that's A. Is A increasing or decreasing at time 5? So all I need is to A prime of 5 then is, it will be the derivative of my y3. I have that in for y3, right? So the derivative of y3 at 5. No, just y3 at 5. y3, sorry, not the derivative of, because that is, the derivative of A is my y3. So just y3 at 5. So negative 1.859. Okay? Yeah, that is a mistake I have seen kids make. They take the derivative of this. If you take the derivative of that, you're getting A double prime, not A prime. You just want A prime, so you just want to put 5 in for T. That's it. Okay? So A prime of 5 is less than 0. Therefore, A of T is decreasing at time 5. This was worth 2 points. 1 point, this is what they said, compares G of 5 to 100, and then 1 point for the conclusion. So did we compare G of 5 to 100? I say that would be one way to do this. This would be one we kind of did, because G of 5 minus 100 is this. We did in a way, but we just did it in a different, we formatted it differently. So we would definitely get full credit for this. Okay? Part D. What is the maximum amount? Absolute maximum amount. I already am thinking closed interval test. That's my thought process. What's the maximum amount of unprocessed gravel, so the max A, at the plant during the hours of operation, 0 to 8? So closed interval test with our amount 0 to 8. So we know that we want to put any numbers, any values of t that make a prime 0, and specifically go from positive to negative. So I will say that a prime of t is equal to 0 at t equals, remember that a prime is our y3. A prime is our y3. So I'm going to turn off y1, turn off y2, keep y3, and I'm going to keep that 0 there because I'm going to find where a prime is 0. My window, I just want to go from 0 to 8. My ymin, ymax just needs to include 0. This might give us a nice screen, it might give us a lousy screen. We won't know until we try it, so let's go try it. Well, not so good of a screen. However, we did get that 0, right? We did get that 0. We got something else too. I find that my a prime is only going from positive to negative. It's only going positive to negative. It starts out positive, it ends negative, and that's all it does. So that means that a is increasing until this time, and a is decreasing after that time. So this has to be not only a relative max, this is my absolute max. It has to be. Okay? So in this one, we don't have to finish our closed interval test at all. We can just use another rationale for it. Okay? The closed interval test would definitely work here. We just don't have to finish it that way. Okay, so I'm going to find that time, second calc, intersect, enter, 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 and it gives me that time that is our relative max, and that time has to be our absolute max. Okay. If you want to, you can say, hey, let me let that equal b, and then you could just put b over here, and that works too. Okay. So now, I started by using the closed interval test, but I'm not going to use that. I'm going to use my rationale that that has to be my absolute max. It has to be. So I'm going to say, all right, a prime is greater than 0 on 0 to b, okay? And that means a is increasing on that interval. A prime is less than, let me say like that, less than 0 on b to 8, and that means that a is decreasing here. So a is increasing and then a is decreasing, so we have a relative max and an absolute max on that closed interval. Okay? So the maximum amount of unprocessed gravel at the plant during the workday is now maximum. I got too many of that. Anyway, you would respell that. Okay. So we want the amount, right? The maximum amount. They asked for what is the maximum amount. I haven't quite found that yet. I need to go and find that, right? So I'm going to find that right here, and I'm going to use the fundamental theorem, because I know I know what the amount was at time 0. So I can find the amount at any other time. So the amount at time B, must equal the original amount at time 0 plus the integral from 0 to 8, 0 to b of a prime. So that is 500 plus the integral 0 to b of my rate in minus my rate out, and that is, okay, before I do anything, X store, I'm going to store that in for B, just like my paper says here. Okay. 500 plus math 9, 0 to B, that's my Y3. And that is the maximum amount, 635.376. Okay, I always take another look at the problem and make sure I answered what they were asking for. Did they want the time? Did they want the amount? You know, make sure that you gave them what they were asking for. Okay. This part was worth 3 points, you guys. 3 points. 1 point for considers a prime of t is equal to 0, which we definitely considered. Okay, 1 point, I'm going to run out of room here, 1 point for the answer, 1 point for the justification. Okay. So again, you get every point you can out of these, all right? Get every point you can. If it's just considering a prime is equal to 0, you guys can totally do that on this problem, right? So even if you mess up somewhere else, get those, all right? Let's take a look at the BC problem from 2010, number 1, with a calculator. I know this sounds like it was a long time ago, but this is a nice little problem. It's nice because it's pretty conceptual, but yet it's set up in a way that we can understand the situation pretty well. There is no snow on Janet's driveway when snow begins to fall at midnight. From midnight to 9 a.m., snow accumulates on the driveway at this rate. So snow is entering at this rate. This is our rate in. Okay, cubic feet per hour. T is measured in hours since midnight. Okay, Janet starts removing snow at 6 a.m. T equals 6. The rate G in cubic feet per hour at which Janet removes snow from the driveway is modeled by G of T here. So G of T is our rate out. If we let A be the amount of snow on the driveway, and I'm writing this here just for you guys. I will write it down here when I need it, okay? But this is just for you guys. This is, if A is the amount of snow on the driveway, then A prime will be rate in minus rate out. And I know that G is a little piecewise function. I know that's a little confusing to you guys, but if we take this just step at a time, steps that we know, we can get through this problem, okay? So in my calculator, I will let Y1 be my rate in. I will let my Y2 be my rate out. I say that, but I'm not going to put these in for Y2, okay? So since I'm not going to do that, it is piecewise, I'm not going to do that. So I won't have a Y3 is my Y1 minus Y2 in this one. I'll just have to take that as it comes. But saying this is going to be helpful to me, okay? All right. How many cubic feet of snow have accumulated on the driveway by 6 a.m.? So this is before any removal began. It's just how much accumulated. So that is our integral 0 to 6, because it's by 6 a.m., 0 to 6, of just my RateIn dt. Okay? So in my calculator, I certainly am going to put that in for my y1. Let me get rid of everything else. I think I'll leave the 0 just in case I need it later. Okay, 7t e to the cosine t. I always check it, make sure I put it in right. Okay, so integral 0 to 6 y1 so 142.275. They would also accept 274, and they did not ask me for units. They actually gave the units, cubic feet of snow. All right, this part was worth 2 points. 1 point for the integral, 1 point for the answer. Okay, part B. Find the rate of change of the volume of snow. That's our A. I'll tell them that, but that's going to be our A on the driveway at 8 a.m. Okay, so we want to know what is the rate of change of A at 8 a.m. So I'm going to say that. Let A of t equal the amount, which is also the volume, of snow on the driveway at time t. Now let A of t be that. Then the rate of change of A prime of t, is my f of t, rate in, minus my rate out. So at 8 a.m., A prime of 8 will be f of 8 minus g of 8. Okay? Well, f of 8, I can stick in my calculator and get a number for. G of 8, if I go to find g of 8, I would use the 108 because 8 is between 7 and 9, so g of 8 is 108. And that gives me, so I need f at 8, that's my y1 at 8, minus 108. So that is the rate of change of the amount of snow on the driveway. So she's shoveling faster than the snow is falling at that point. So negative 59.583. They would also accept 582 back there. Okay. This question was worth 1 point just for the answer. Okay, part C. Let h of t represent the total amount of snow in cubic feet that Janet has removed. H of t is the amount of snow removed. A of t, remember, was the amount of snow on the driveway. So now we have h of t, which is the amount of snow that has been removed from the driveway at time t. Express h as a piecewise function from 0 to 9. Okay, so h is the amount of snow that has been removed. All right, so first of all, h is going to depend on the rate of removal, right? And from 0 to 6, nothing has been removed. The rate is 0, so nothing has been removed. So on the time from 0 to 6, I'm not including 6 because I'm looking up here and I'm saying, okay, that didn't include 6, so I'm not going to include 6 right there. Okay. On 0 to 6, h of t is equal to 0. Okay, I'm going to write that here, and then at the end I'll write it as a nice piecewise function with a nice little one-sided brace. Okay. Now I'd like to go and consider the next step. So the next step is from 6 to 7. Include 6, don't include 7. So on 6 to 7, all right, h of t is going to the amount, I'm going to set up a little fundamental theorem because I know that h prime is my g of t, right? H prime is my g of t. So I can set up a little fundamental theorem here. So on 6 to 7, h at any time minus h at the time this interval began, h of 6, is going to equal the integral from 6 to that time to any time of h prime. But h prime is my g of t there. So that will be 125. H of 6 I can use up here. At time 6, h was 0. So we're starting with nothing removed, right? That makes sense here because the rate was 0 up until 6. And then right at 6 we start working, but there's not going to be anything removed right at that instant. Yes? So h of t is going to equal, I'm going to take that over, but it's just 0, plus integral from 6 to t of my g of t at that time interval, so 125. Just a constant. We know how to integrate just a constant. Take that constant and multiply by the difference b minus a. So that gives us our little piece for h in that interval. Now we're going to do the same thing for the next interval from 7 to 9. So from 7 to 9, h of t minus h of 7 will equal the integral from 7 to t of h prime in that interval. Okay? So h of t will equal, okay, h of 7. Well, we can come up here and use this value, h at 7, from this expression. If we put 7 in for t, we just get 1 here, and 1 times 125 is just 125. So h of 7, the starting spot here, is 125. H prime is g of t for this interval. That's our 108. So this will be 125 plus 108 times t minus 7. So I can combine this and make it a nice, neat little piecewise function. So h of t is equal to, nice, neat little piecewise function. Okay, for the first piece, 0. For the second piece, 125 times t minus 6. And for the last piece, 125 plus 108 times t minus 7. And this is good. This 0 is good on 0 to 6. The second piece is good from 6 to 7. And the last piece is good from 7 to 9. And don't forget, you're going to have tons of space on yours. I didn't include tons of space here just to save a little paper, but you will have tons of space on yours. All right, this part of the problem was worth 3 points. 1 point for h prime for 0 to 6, 1 point for h on 6 to 7, and 1 point for h on 7 to 9. 3 points. Okay? All right. Part D. How many cubic feet of snow are on the driveway at 9 a.m.? So remember, from midnight to 6 a.m., the snow accumulated, and we know how much was on there at 6 a.m. Okay? At 6 a.m. though, Janet started to shovel snow. Okay? Snow kept on falling, but she was also shoveling at a pretty decent rate, because remember, her rate at 8 a.m. the snow was being removed at that rate. Okay? So how many cubic feet are on the driveway at 9 a.m.? Well, let's find out. We found out in Part A that at 9 a.m., we know how much snow had fallen onto the driveway. Okay? So, I'm sorry, I think I said 9 a.m. At 6 a.m., this is the amount of snow that's on the driveway, right? So A at 6, we know is 142.275. We know that from Part A, right? There's no snow at midnight, and then this amount at 6 a.m. Okay? So I'm going to go to my first little time segment. I'm going to set up the first fundamental theorem. At time 7, the amount at time 7 minus the amount at time 6 must equal the integral from 6 to 7 of A prime. And A prime, I set up here what A prime was. A prime is F minus G. Rate in minus rate out. So A of 7 will be 142.275 plus the integral from 7 to 6 of, okay, this is my F of t minus my G of t. And I wrote it because G of t is special for this interval, right? So 142.275 plus, I'm going to split this up into its two pieces. Actually, I'm not going to split it up. I'm just going to write G of t for this section. G of t is 125. Yeah, I can do that. And then I can get that number just in my calculator, right? F of t is still stored in for my y1. So I can go to my calculator, 142.275 plus math 9, 6 to 7, F of t minus 125. So 133.313. Okay, but that's the exact, I'm going to use the exact number when I go to the next step. Okay, now I go to the last time interval. The amount at 9 a.m. minus the amount at 7 a.m. must equal the integral from 7 to 9 of A prime, right? A prime is F of t minus G of t on that time interval, which is 108. That's G of t at that time interval. So A of 9 must equal, there's my A of 7, right? Plus this integral. So I'm going to take that number, and then I'm going to add to that number the integral from 7 to 9 of F of t minus G of t on that time interval. 26.335. That's cubic feet of snow on the driveway at 9 a.m. So she got rid of quite a bit of snow. All right, this part of the problem was worth 3 points total. 1 point for the integral, 1 point for h of 9, h of 9, h of 9. I think we meant a of 9 there, because we're not dealing with h of 9. And 1 point for the answer. 3 points total. I was seeing that it was h of 9 here. It made me question it. I think it was h of 9, and it made me think of another way we could have done this problem that you may have done on your own when you did this problem. We could have found a at 9. We could have found the amount of snow that fell. The amount of snow that fell from 0 to 9. We could have found 0 to 9 of f of t. And that would be the amount of snow that fell from 0 to 9. And then we could have just taken that and subtracted out h of 9. And that would have given us our answer all in one fell swoop. Okay? It's a little bit more elegant than my way of thinking. Now, I think my way works, but that stuff. And let's go ahead and try that. So, Math 9, 0 to 9 of f of t, that's our y1, minus, so I'm coming up here to our h function, and I'm putting in 9 for t, so that will be a 2 back here. So we'll have, I'm going to put this in parentheses since I'm subtracting the amount that was removed. 125 plus 108 times 2. And I get the same answer that I got. So, wow, okay. I'm really hoping somebody else did it like this, and then you can say, ha, I did it a much more elegant way than Mrs. Murray did. Both ways work though, so hey. Alrighty, we have one more to do in this little packet. This is way back from 2005, and I pulled this out. I just liked this problem. It's a very straightforward problem. This would be a great problem just to start with this topic. Very, very basic rate in, rate out. Okay, so we're ending with it, so it'll be still a good problem. Okay, the tide removes sand from sandy beach at a rate modeled by R. So this is our rate out because sand is being removed. Okay. A pumping station adds sand to the beach at a rate modeled by S. So this is the rate that sand is being added, so this is our rate in. So be careful when you read these. Make sure you get your rate out and your rate in correct here, okay? R and S have units of cubic yards per hour in case we need some units. T is measured in hours. T is between 0 and 6. And then at time 0, the beach contains 2,500 cubic yards of sand. So there's our initial condition. At time 0, the amount of sand is 2,500 cubic yards. Okay, part A. How much sand will the tide remove from the beach during the 6-hour period? So how much sand will the tide remove? Just remove. Doesn't have anything to do with being added, right? So we're only going to use our R function. The amount of sand being removed in the 6-hour time period is just the integral from 0 to 6 of r. Okay, calculator time. I'm going to go to my y equals screen. I'm going to put, so you guys, I'm going to put my RateIn, my S, in for y1. 15t divided by, put parentheses around that denominator because there's more than one term, right? Like that. And then in for y2, I will put my RateOut. For pi t divided by 25. I'm always checking these. It's so easy to type it in wrong. And then you're just in trouble. And then I'm going to go ahead and put RateIn minus RateOut for my y3. Okay, so that's all in there. I can use that for the whole problem. So RateOut is my y2, so on my home screen I'm going to do math 9, 0 to 6 of my y2, that's my RateOut. 31.816. AP will also accept 31.815. Okay. Indicate units of measure. All right, this is the amount of sand removed. So my units for amount of sand is cubic yards. Okay, that's it. That was worth 2 points. 1 point for the integral, 1 point for the answer with units. Okay, part B. Write an expression for y of t, the total number of cubic yards of sand on the beach at time t. All right, so they're telling me I need to call the amount y. All right, so I was calling it a up here. I like to call it a, but they're going to tell me to use y, so that's what I will call it. Okay, so y of t is the amount of sand. And I don't need to write this again. They just told me what it was, so I don't know why I was writing it. So we want to write an expression for the amount of sand. Okay. So I'm going to set up a little fundamental theorem of calculus equation here. The amount of sand at any time minus the amount of sand at the beginning, because that's what I know, must equal integral 0 to that time of y prime. Okay? Y of 0 is 2500. Y prime is RateIn minus RateOut. That's my S of t minus R of t dt. Okay? What we could have done up here is said, okay, I want to write this in another color. What I could have done up here is I could have said, so Y prime is equal to S of t minus R of t, and then we could have just left it like that, and that would have been fine as well. Now, if it bothers you, this is fine to write it like this, that's not a problem, but if it bothers you to see t's here and a t there, you can totally change this, make these x's or some other letter there, some other letter that's not being used in the problem, okay? But I don't have a problem with the t's all over the place, neither does AP, all right? Neither do the graders. So that's fine for me, okay? All right. That part, you guys, was worth 3 points. 1 point for the integral, for the, integrand. Okay, 1 point for the integrand, 1 point for the limits, 1 point for the answer. So 3 points. This is a very kind of a theoretical question, okay, writing this expression for the amount. It's kind of theoretical because we have this t here, right? That makes it a good question for the 2020 test, FYI. I expect that will be a very theoretical test, conceptual test. All right. Find the rate at which the total amount of sand is changing at time 4. Find the rate the amount of sand is changing at time 4. So we're looking for y prime at 4. Y is the amount. We want the rate of the amount at time 4. That's this. So that will be, and we set it right here, well, that will be S of 4 minus R of 4. It's also our Y3. It's also our Y3 because Y3 is S minus R for us. So I can just do Y3 at 4. So negative 1.909. Or they would take negative 1.908. So this was just worth 1 point for the answer. And this last part. On the total time interval 0 to 6, at what time is the amount of sand a minimum? Amount of sand a minimum. Closed interval test. So we want the time and we want the value. Okay, both. So time, and we are minimizing y, 0 to 6. I need to put when y prime is 0, specifically when y prime goes from negative to positive, but I'm going to write them both here. Well, if there are two, I don't know how many there are. I haven't looked at this in a long time. Okay, so in my y equals screen, y prime is my rate in minus rate out. So turn off y1, turn off y2. I'm going to keep these last two things here. And for my window, I only want to see 0 to 6. I don't want anything else to distract me. So just do your 0 to 6 here, okay? For our y min, y max, just make sure we're including 0, which we are, so I'm just going to leave it like that. All right, so this is okay, but I'm not sure if we're going over the x-axis here. It doesn't look like we are, but I'm not positive. So I am going to decrease my y values. I'm going to go, this is from negative 10 to 10. I think I'm going to go from negative 3 to 3, just to make sure nothing funky is happening down there. Okay, now I'm sure. So that was fine. Okay. So there is just the one time that y prime is changing signs, okay? And that one time, y prime goes from negative to positive. So the amount of snow is decreasing from 0 to that time, and then the amount of snow is increasing. I say snow, sand. We're with sand here. The amount of sand is decreasing from 0 to this time, and then the amount of sand is increasing from that time to 6. So again, I started with the closed interval test. I could finish with it, but I don't have to in this case. We certainly could if we wanted to, though. All right? It really wouldn't be that much harder to do that, to finish it with the closed interval test. But we don't have to here. Okay, so I'm going to find that time, find the intersection point between this curve and 0. So that's the time. So at t equals 5.1178, I'm just going to give it a little dot, dot, dot. I'm going to call that, I guess I can call it A this time because I'm not using A in the problem. And then I can just put A on my closed interval test. right? I can come back here and store my x value in for A. So now A is that in my calculator. We're good to go. So do you see that we could find the amount at these three values and then just take the lowest one, and that would definitely work, okay? Or we could use the fact that y prime is negative from 0 to A, so y is decreasing there, and y prime is positive from A to 6, so y is increasing there. Therefore, the minimum value must be blah, 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 okay? So I'm going to go ahead and find that minimum value. I'm going to use the closed interval, the fundamental theorem of calculus to find that. So y at time A minus y at time 0, which we know, is the integral from 0 to A of y prime dt. So y of A is equal to y of 0, which is 2500, plus that integral. And this is, I've said what it is up here, but that is my rate in minus my rate out. So I have 2500 plus math 9, 0 to A of my y3. This will be the minimum amount of sand on the beach at that in this time interval. So 2492.369, and that's the only acceptable answer there. Okay. And you know what? Now that I've done that, I think I will just finish with the closed interval test. Either way is fine. So this is, I'm going to rewrite that there. Do I need to round it? No, don't need to round it. At 0, we're at 2500. I'm just going to quickly find, I know this won't be my right answer, but I'm going to quickly find it because that completes my closed interval test. And if we're using the closed interval test for our justification, we need to complete it. All right? So I'm going to go ahead and complete that. Y at 6 minus y at 0 is integral 0 to 6 of y prime. So y at 6 is equal to 2500 plus that integral. So 2500, you know what I'm going to do? I'm just going to come grab this and change that A to a 6. So 2493.277. So yes, this is the minimum. So the amount of sand is a minimum at time 5.118. The minimum amount is 2492.369. And again, if you want to say by closed interval test, that's fine, but since we finished with closed interval test, that's fine as well. Okay, that's it. This ended up being a long video. It's going to take a while to upload, but that's okay. All right, guys, that was, hopefully you can fast forward. You fast forwarded to what you needed and got everything you wanted. Come see me in tutoring or on Zoom if you have further questions about these. Okay.